Good evening, everyone, and thank you for staying back and going through this last session. I'll just take the help of a small video to sort of get everyone in the mood before we talk a little more about the applications of some of the core tech that we are developing, and also, the impact that we as a country need to sort of get and put together given this whole emerging geopolitical situation.
Ukrainian forces have now launched their much-talked-about counteroffensive,
expected to be the biggest military operation in Europe since World War II.
The future of war isn't coming. It's already buzzing overhead. In 2025, drones are no longer just eyes in the sky. They're packing guns and making decisions on their own. From Ukraine's battlefields to India's high-tech defense trials, gun drones are redefining modern combat.
देवी और सज्जनों, आप अपनी बाईं और दाईं ओर देख सकते हैं 75 सशक्त ड्रोन्स उड़ान भरते हुए। ये स्वचालित ड्रोन्स बिना किसी मानव हस्तक्षेप के दिखाए गए दुश्मन के इलाके में तकरीबन 50 किलोमीटर अंदर घुसकर अपने मिशन को एक सफल अंजाम देंगे।
Please take your attention to the terror hideout Tango 11 on your right to witness the kamikaze kinetic strike. Now please turn your attention to the tank on the left to witness a second kamikaze kinetic strike on enemy tank depicted by Tango 3.
And now, ladies and gentlemen, please take your attention back to the screens in front, where you can see a detachment of drones carrying out the search for their targets, technically called as foraging using the onboard AI edge computing. The enemy mortar positions acquired. Enemy tanks identified.
Right, so just a small glimpse of some of the technologies that we have built. A large part of what we sort of build is not something that we can show, but we sort of taken from what we can sort of speak about, and that's where we are here. So what is this, swarm technology everybody seems to be sort of talking about, right? So I think it's important to understand that by far and large, most of the technology developments have happened in two parts. The first part is that there's been a lot of money that has gone into defense historically, and from the defense sector, we have seen technologies emerge and come into the civilian side. In the last 5 years, we've seen the reverse flow. We can now see that technology from the civilian side is now getting into tech and therefore making it more and more potent as we sort of move forward. This is one aspect of it. The other aspect of this is about, our mimicking animal behavior. So a lot of what we develop as technology, especially in the war front, is trying to see how does nature behave in areas of conflict, in areas of cooperation, in areas of their survival. And that is what has actually helped us to build this entire stack. Write the algos, put the layers of AI and the rest of it, and sort of emerge as part of it. So fundamentally, And as always, the pain is the maximum with the defense. And, that's where the solutions of what we can build sort of goes in. And that is how this whole ability to apply swarming technology onto military defense has sort of emerged. So swarming is essentially, a composition of two things. The first part of this is what we call as collective robotics, which is how do you get robots to work together. And the second part of this is about distributed intelligence. How do you ensure that the intelligence that you are building is therefore distributed and is available to all elements of the swarm, all nodes of the swarm together. So there are three, very simple, I would say, hierarchies. The first is, of course, centralized, which is that you make one node the intelligence node and sort of ensure that everything sort of goes in there, and then you distribute the actions and you distribute the point to the rest of the drones. Now you move to the second level, and this is, the first is almost about, I would say, more than 10 years old in terms of the way that we have developed systems. And then we move to what we call as subnodes, where you have these, very simple agents and squads which do lower level, action decisions, and then escalate it to the higher node, and therefore they are able to work. And of course, the last, which is the place that we are in right now, is about literally having a virtual node. And no matter what happens to the actual physical nodes, this virtual node keeps on ensuring that the rest of the nodes have the same intelligence and the same hierarchy of objectives, and they continue to operate over time, even if the bulk of them are destroyed. Just a quick, simple example. So if you look at a 20 drone, system, so it's broken up into 4 categories. The first one are essentially locators. They will go out, they will search and identify fundamentally radio targets. Okay? And then you have air data relays. Basically, it means that if you're very deep inside enemy territory, your ability to communicate with them will require that you are able to daisy chain each of your telecom and your comm network. So you build that. Then you have your third layer, which is largely intelligence, surveillance, reconnaissance. You figure out who are objecting to what you have, what is the lay of the land, what sort of objects are around, and then you plan. And then, of course, the hard kill. Now, these are all part of one unit. Okay, so it's a system of systems. 4 different kinds of UAVs. They get together and they sort of work forward. Very, very simple sort of example on how we want to do. What we demonstrated, you would see on the video, the 75 drones. This is the ground control station view. So basically 75 heterogeneous swarms in a matter of 18 minutes, more than 13 operations, fully done on their own, just managed by 2 operators. So this force multiplier dramatically changes the way that we would use autonomous systems, and especially heterogeneous robotic systems, in the way that we are sort of moving forward. Again, this is one of those videos which was actually built for the Army, so I can show that to you. I'll talk you through so that you're able to see. So first important part is that these are not pre-planned. So you'll see that all of them are independently moving, detecting where the others are, and therefore creating their own flight path, and then they decide to move forward. Their objective is to identify certain targets, which they are then able to do it through onboard classifiers and visualizers. There's a lot of CVML at play here. Then there's an area which is designated, which is a suspected area where there is potentially some object, and they cover that area and identify them. And of course, all of this happens in an environment where it is extremely important for us to ensure that the communication is on. So there is, of course, self-healing as part of it, but more than that, this chirping of the communication nodes is the most critical part. You cannot be speaking too loudly, and there are communication jammed environments, so you have to be able to reform and recreate as quickly as possible. Also, what you just saw was a tank operator who took control of, out of the 24 of them, and reassigned them to a separate task. So how do the ground forces work with the air forces as well? You would have seen many of these videos in Ukraine. And again, just back to that, the ground station view that we had. So just very quickly, the second part about, very core application is disaster management. They can happen at any time, anywhere in the world, could be man-made, could be, natural as well. So there are phases through which the operations happen in each one of them. And one of the core operation, which is being aware and being ready, is something that there's a lot of satellites and a lot of ISRs and UAVs which are there. There's not much of a play there. The second part is about how do you assess and how do you sort of do the response. The first 48 hours are the most critical for survivors. The only way that you can sort of carry out rescue operations is to first be able to locate them. So very quickly you would sort of send out a swarm of the UAVs with all the detection tools. They are able to quickly go, scan, and then see where are the operators. The second part is that mostly when there is a natural disaster, the entire terrain changes. So maps change, roads collapses, rivers sort of go up. So even relief work cannot go. So these swarms, in a very collaborative manner, they can recreate the entire maps for that area and therefore help them. The third aspect about this is comm. So most of the networks collapse, your tower cells, they fall down. So a swarm of these UAVs are very quickly able to go into that area. They carry different transmitters, and therefore they are able to sort of work this out. This is something that we had demonstrated to the Japanese about a year and a half ago. All of these leads to the fundamental, I would say the first requirement in any sort of a disaster, which is to ensure that the survivors are taken care of, they are identified, and therefore there is immediate and fast relief that can sort of work this out. Logistics is the second big play. So you can imagine that right now we have close to about 40 plus airports in the country. E-commerce is sort of really growing very, very fast and strong. And within that whole construct, the challenge of ensuring that you are able to do express deliveries is a very, very big one, because you can only fly up to these 43 plus locations. So one of the concepts that we are sort of working on is how do you ensure that you have a very, very fast and agile middle mile. Take away the requirement of master warehouses, go from a warehouse to another warehouse, use a hub and spoke model to ensure that you are also able to distribute. Largely our focus is on B2B, and this is something that we are sort of very, very quickly and fast working on. It's a quick one. We have a patent on this. It took a long time for us to actually get this, so I'll just put it out there. Now, all our tech is sort of put together in a very, I would say, unique application, which would have been very relevant based on the incident that created Operation Sindoor. So this is a project that we have done. This was for DRDO. And the whole idea was that how do you get into a forest without actually going in, and ensuring that you are able to therefore navigate the trees, the bushes. How are you able to therefore look at targets inside, scan that area. So extremely complex. You have to keep in mind that bulk of the compute that is happening, so this is all edge computing here. There is only one of them which is connected to one ground station, which is roughly about 2 to 3 kilometers away. And they just get inside, they have on board, so multiple sensors on board, and they are able to completely work on their own. This is probably one of the most complex applications of edge computing with sensor fusion and, of course, swarm intelligence. I mean, just imagine if we had this in operation in Pahalgam, we would have been able to spot all the terrorists at least days ahead of their execution. So the good part is that even if they are taken out and they are shot down, you at least get to know that there is somebody inside. And every soldier saved, is a big, big value for us. So the next part about this is what happens if there's a comm jam environment, right? So you have inertial navigation, you are able to route, do a SLAM architecture, figure out the entire play about what is the construct of that entire play. So even if you want to do night operations after having built this out, that whole map is available for the soldier to sort of build in and go in. And they come out of the other side. Yeah. Right, so a lot of companies are claiming a lot of things about Operation Sindoor. I'll just say that the world's first high-density swarm was supplied by us, and it was inducted in the military in 2013. Yeah. So that's all I have. I think there's a shortage of time. Thank you all very much. Thank you.